All right, this is Mr. Wyrick, and today we're going to be talking about the Chapter 8 review. First off, on number 1, the geometric mean of 8 and 12. When you set this up, this is just going to be 8 over x is equal to x over 12. You cross multiply, and you get x squared is equal to 96. That means you're going to take the square root of these. Now, it does say reduce the radical, and on your test, it's multiple choice, but it says reduce the radical, and it gives you reduced radicals. We're not doing that. I'm not going to go back over how to do that. We're not going to mess with that. You might mess with that in Algebra 2, but we're just not going to do it, okay? When you come to that point, if you're struggling, what you really need to do is just enter the answers into your calculator. So on this one, if we take the square root of 96, for example, the square root of 96, we're going to get 9.797, or basically like 9.8 is what I'm going to call it. X equals 9.8. Now, if you were to reduce the square root of 96, which I'll do this again real fast. I don't remember if you did this in Algebra 1. So we got 96. That's divisible by 2. It would be 48. That's divisible by 2. That's 24. That's divisible by 2, that's 12, that's divisible by 2, that's 6, that's divisible by 2, that's 3, that's divisible by 3, that's 1. Pair of 2s. So this is going to be 2 times 2, 4 square root of 6 is what it would say. But if this were your answer, you can type in 4 square root of 6 on your calculator and get the exact same decimal answer that we got when we just typed it in the calculator. So for numbers 1 and 2 on the test, that's what you'll have to do, is just type it into the calculator, compare, make sure your answer is the same one and the one that looks the best. Geometric mean of 4 and 25 is going to be 4 over x is equal to x over 25. Cross multiply, you get x squared is equal to 100. So x is just 10 when you take the square root. On this one, the missing length, this is geometric mean again. X over 36 is equal to 64 over x. So you cross multiply, you get x squared. 64 times 36 is 2,304. You take the square root of both of those, and you come up with x is 48. It makes sense because both of these are perfect squares. Okay, we don't have a decimal. Find the missing side of each triangle. Round your answers to the nearest tenth. On this one, this is a right triangle. You are going to use the Pythagorean Theorem. This is the A side, this is the B side, this is C, and it's A squared plus B squared is equal to C squared. So 4.1 squared plus 12.1 squared is equal to x squared. We can take the square root of both sides so that you can type this in all at once. The square root of 4.1 squared plus 12.1 squared is going to be 12.775. The nearest tenth is 1 decimal place. Remember, you can go second decimal 1 for 1 decimal place, making this x is 12.8. It should always be the biggest side. So if I'm looking at a multiple choice test and I'm looking at a bunch of options for this one and I don't know what to put, make sure to cross off any that are smaller than any of the sides. The hypotenuse has to be the biggest side. On this one, state if it's acute, obtuse, or right. All we're going to do is a squared plus b squared, and then we're going to do c squared. If a squared plus b squared is greater than c squared, that's acute. If a squared plus b squared is less than c squared, it's obtuse, and if they are equal, it's a right triangle. So this is my c. So I go 8.4 squared plus 4 squared. 8.4 squared plus 4 squared. That's going to be 86.6. I do 11.6 squared. 11.6 squared is 134.6. That is bigger. This triangle is obtuse. It can't be a 90-degree angle. It has to open too wide to be a 90-degree angle. That's going to make it obtuse. On this one, I do 28.8 squared plus 3.4 squared. And I come up with 841. I do 29 squared, and I also come up with 841. Those are equal. This is a right triangle because only on a right triangle does the Pythagorean theorem come up equal. On this one, number 7, it's the exact same thing as numbers 5 and 6. It's just there's no picture of a triangle this time. You do 22 squared plus 58.5 squared. We come up with 3,906.3 because I still have it rounded to a single decimal. I should probably undo that. I'll put it back on float. Yeah, 3,906.25. I check 62.5 squared. And I come up with 3,906.25. Those are equal. This is a right triangle. Okay, again, it's exactly the same as 5 and 6. There's just not a drawing of a triangle. You can draw one in if you want. Somebody want to grab the door? On number 8, we have special right triangles. These are 45, 45, 90. Right triangles, both of them. So if these are both 45, 45, 90 right triangles, that means two things. Number one, this is basically the diagonal of a square. It's because two of the angles are the same. It's an isosceles triangle, which means two of my sides are going to be the same. If this side is 7, then the other side down here, y, is also 7. The hypotenuse of this triangle is over here on x. That's going to be 7 times the square root of 2. On number 9, exact same thing, okay? The side times the square root of 2 is going to make the hypotenuse, but on this one, my hypotenuse is 10. So instead of trying to multiply by the square root of 2, I have to divide by it. That's not easy to do. So just remember, you divide it basically by 2. Half of 10 is going to be 5. So x and y, since they're the sides, they're going to be exactly the same. It's going to be 5 times the square root of 2. Because that way, when I multiply this 5 square root of 2 by the square root of 2 to get the hypotenuse, square root of 2 times square root of 2 is 2. That means I have 5 times 2, which is 10. You can also, these are right triangles. These are special right triangles. You can run these through the Pythagorean theorem to see if they work. Because not only does it have to do this special right triangle thing, the Pythagorean theorem has to work. So you can always check your answers with the Pythagorean theorem to see if that comes up right. Numbers 10, 11, and 12 is a 30, 60, 90 right triangle. And on the 30, 60, 90 right triangle, you have the short side. The hypotenuse is double the short side, and the side opposite the 60 is the short side times the square root of 3. So on this first one, they tell you where 60 is. That means we have the side opposite the 30, and it's 4. That means that x, my hypotenuse here, is double that, so it's 8. And y, my side opposite the 60, is that same small number times the square root of 3. On number 11, they give you the hypotenuse. That means the y value, my short side, is half of that. It's 3. And then my x value, the side opposite the 60, is this short side times the square root of 3. On number 12, they give us the side opposite the 60, and it's 9. Just like we had to divide by 2 and then multiply by the square root of 2, this was our pattern paper. We are going to divide this number by 3 and then multiply it by the square root of 3. My short side is 3 square root of 3. And that means that my hypotenuse is going to be double that, which means letter A is 6 square root of 3. Now, on 13 through 20, this is the biggest portion of the, or 13 through 21, this is the biggest portion of the review. This is the biggest portion of the test. All right? and it's the trig functions. It's sine is equal to the opposite over the hypotenuse, cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. Okay, SOHCAHTOA will be written on the board in here, or if you leave the room, it'll be written on your test. On this one, circle the angle, draw an arrow to the opposite, label the hypotenuse, which is across from the right angle. Circle the angle, look across from it, label the hypotenuse. Circle the angle, look across from it, label the hypotenuse. Circle the angle, look across from it, label the hypotenuse. I do this every single time, and it lets me know exactly what I am supposed to use. On these first two, I have the opposite side. I'm looking for the hypotenuse. That means the sine is what I'm using, opposite and hypotenuse. The sine of 49 is equal to x over 13. On this one, the sine of 44 is equal to 10 over x. The difference is how we work these out. This one has x divided by 13, so I multiply by 13 to get rid of the fraction, times 13. 13 times the sine of 49 is equal to x. That's what you will literally type into your calculator. 13 sine of 49. And I'm supposed to round to the nearest tenth. That's 1 decimal place. These instructions for converting to 1 decimal place are written on the test. So it's 9.8. X is 9.8. Okay, I'm going to set all the rest of these up. I won't worry about working them out, just to kind of save time on the video. On this one, though, the x is on the bottom. I'm going to swap these. So this is x is equal to 10 over the sine of 44. That's exactly what I'm going to type in. 10 divided by the sine of 44. That gives me 14.4. X is 14.4. Okay, again, I'm looking for my hypotenuse. It should be the longest side of the triangle. I make sure it's the longest side of the triangle. I'm feeling good about it. On number 15, I don't have the opposite. I can't use sine or tangent because I don't have the opposite side. This is cosine. The cosine of 34 is equal to the adjacent side of x over the hypotenuse of 20. I've labeled the hypotenuse. I always label my hypotenuse. I've labeled the hypotenuse. I know what to put where. I don't have the opposite side. This is the cosine of 27 is equal to 11 over my hypotenuse of x. Again, on the number 15, I'm going to multiply both sides by 20. On number 16, I'm going to swap and have 11 over the cosine of 27. On number 17, I have the opposite side, but I don't have my hypotenuse. I'm going to use tangent. The tangent of 59 is equal to the opposite side of 10 over my adjacent side of x. On number 18, the tangent of 71 is equal to my opposite side of x over my adjacent side of 12. On numbers 19, 20, and 21, don't get confused because it looks like a different section. We're still doing the trig functions. It's still sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I circle, I look for the opposite side, I label my hypotenuse. I circle, I look for the opposite side, I label my hypotenuse. I circle, I look for the opposite side, I label my hypotenuse. This one, I have my opposite and my hypotenuse. It's going to be the sine. I don't have my angle. That's theta. Sine of theta is the opposite of 46 over the hypotenuse of 54. In order to move the sine away to where I can solve this on my calculator, theta is the inverse sine of 46 over 54. This is exactly how I'm going to type it into the calculator. I don't have to do anything complicated. The inverse sine is the second function right above the sine button. So I push second and sine. That gives me that inverse sine. Sine to the negative 1 power. The inverse sine of 46 divided by 54 is 58.4. I go 0 decimal places. It's 58. Theta is 58. I have a 58-degree angle to the nearest degree. So 20 is going to be, I don't have my opposite. This is the cosine of theta is equal to the adjacent of 56 over my hypotenuse of 59. So that's theta is equal to the inverse cosine of 56 over 59. And on this one, the tangent of theta is equal to the opposite side of 22 over my adjacent side of 25. That means theta is the inverse tangent of 22 over 25. Hopefully this will guide you pretty well through the test. If you have questions, make sure to come in before we take the test and ask those questions. And good luck.